In this video, I'll show you how to solve the ALEKS problem called using a chemical equation to find moles of product from moles of a reactant. This problem is going to start with a description of a chemical reaction, and then it's going to ask us to perform some sort of calculation based on a couple of the molecules in the reaction. So let's begin with step one for this problem. Step one is going to be taking this information at the very beginning of the problem and using it to write and balance a chemical equation. ALEKS is going to provide you with everything you need to know to write and balance this to write the chemical equation. And all you have to do is just read this and just kind of copy information down as you're reading it. So mine says that I have acetylene, which is C2H2, and it's a gas, but we don't need to worry about state. Solid, liquid, gas, doesn't matter. It's used in welding torches, blah, 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 blah. It reacts with O2. So reacts with means that I am adding it to O2. And then it says it produces, so that is our indication that we need our reaction arrow, and it produces carbon dioxide gas and water vapor. Those are the two products. For most of these problems in ALEKS, it actually gives you the chemical formulas for the reactants and products. For this particular one, it's not giving me the formula for carbon dioxide gas or water. If you don't know what those are, just look them up on the internet. That's not difficult to do. So once we get this equation written out, our next job is to go through the process of balancing it. In order for us to solve this problem, we're actually going to need to have this equation balanced. So what I'm doing is writing out the elements that are in this equation. I have carbon, hydrogen, and oxygen. And I'm going to start by counting up how many of each I have initially. On the left-hand side, I have 2 carbon. On the left-hand side, I have 2 hydrogen, and I also have 2 oxygen. On the right-hand side, I have only 1 carbon. I have 2 hydrogen right here, and then I have 1, 2, 3 oxygen. So I'm going to start by balancing my carbon. I have 2 on the left, which means I also need 2 on the right, and to give me 2 on the right, I'm going to put a 2 in front of the CO2. That's going to change the quantity of the carbon as well as the oxygen. I now have 2 carbons, so my carbons are balanced. For the oxygen, I now have 2 times 2, which is 4, plus 1, which is 5. My carbons are balanced, my hydrogens are balanced. Now I need to balance my oxygen. I have 5 on the right and I need 5 on the left. This is a little bit tricky in a situation like this where I need an odd number of oxygen on the left-hand side, but my oxygen atoms come in 2s, meaning that I could have even numbers of oxygen. I could have 2 or 4 or 6 or 8, but it's going to be difficult for me to get 5 oxygen atoms on the left-hand side because, again, they come in pairs. Whenever you're balancing any equation and you get in this exact situation where you need an odd number of some particular type of atom, but they come in pairs, what I want you to do is pause, go through this equation, and double all of the stoichiometric coefficients. So instead of having 1 C2H2, we're going to change that to a 2. Instead of having 1 O2, we're going to change that to a 2. We're doubling everything. Instead of having 2 CO2s, we're going to change it to a 4. And instead of having 1 H2O, we're going to change that to a 2. So we're just going through and doubling all of these stoichiometric coefficients. That's also going to double all of these quantities. And now we no longer need an odd number of oxygen because when we double an odd number, it turns into an even number. So now we need 10 oxygen atoms on the left, and we're going to get 10 by putting a 5 in front of the O2. So that's just like a little shortcut that I have for dealing with that situation because it does come up pretty often in balancing equations. Okay, so let's take a reminder of what we're doing here. We wrote out a chemical equation based on ALEKS's description of this situation, and then we balanced that equation, and now we need to figure out what ALEKS is asking for us to do. So the next statement in this problem is going to tell us the calculation that we need to perform. In this sentence right here, ALEKS is going to identify 2 of the molecules in this equation that we just balanced. So for mine, it's talking about the water, the moles of water, and it's also talking about the moles of oxygen. And you're going to notice that it's going to give me the quantities for one of those molecules, and it's going to ask me to calculate the quantity of the other molecule. So for my problem, I'm focusing on the water, and the oxygen. And the other two parts of this equation, we're not going to use them at all. They were just there to balance things, but we're not going to deal with them. So what we need to do for this problem is to take this provided quantity, for mine, it's the 0.09 moles of oxygen, and we need to convert that quantity into moles of water. And I like to treat this just like a regular unit conversion problem. Treat it the same way that we would treat it if you were being asked to convert kilograms into grams. So that means that I'm going to start by writing the quantity, 0.090, and also the unit that ALEKS provided to me. I'm just going to copy this down right here, and then I'm going to multiply it by a conversion factor. Again, I'm treating this the same way that I would treat a kilogram to gram conversion. I want my unwanted unit on the bottom of my conversion factor so that it cancels out. My unwanted unit is the moles of O2. I want my desired unit, moles of water, I want the desired unit on the top of my conversion factor. And the actual numbers that I'm going to fit into this conversion factor are the stoichiometric coefficients from the balanced equation. So for water, the stoichiometric coefficient is 2, and that's going to go next to the 2 moles of H2O. And for O2, the stoichiometric coefficient is 5. And this is why this conversion factor is why we need to begin by balancing the equation, because we need to know what the stoichiometric coefficients are in order to balance the equation, or in order to solve the problem. So take a look at how our moles of O2 cancel out. We're going to be left with moles of H2O. Let's do the math. 0.090 times 2 divided by 5 is 0.036, and that unit is moles of H2O. ALEKS says to 2 significant digits, which is exactly what it has, and it says be sure your answer has a unit symbol on it. So the unit symbol that ALEKS specifically wants for this problem is just mole. It doesn't want you to tell moles of what, it just wants mole. So you're going to put in, if this was your problem, 0.036, and then you're going to type MOL. Make sure you use the abbreviation, not MOLE, MOL, and then that's it.